I can't see comments coming in. Tell me the state you are coming from. I'm joining from Jos, Nigeria. Um, I'm joining. Oh, hi Monday. Welcome. Where are you joining us from? Type in the comment section where you are joining us from. I'd love to. From Ocean, Nigeria. Amazing, amazing. Welcome, welcome, welcome. Um, let's the comments keep coming in. Oh, Ogun, Ebonyi State. Wow, that's amazing. Lagos, Nigeria. Amazing. Yeah, Kent is joining from Just. Wow, that's really amazing. Welcome, 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 welcome. So we have like it's one on the dot, 1 minute past one. Let's just like have 4 minutes. With 4 minutes, if more people will join, and then we can, go ahead. Joshua joining from Ogun State, Nigeria. Oh, that's amazing. Welcome. Welcome. So I want to give like opportunity to anybody that wants to speak. Like just tell me why you are here and what you look forward to learning. Or should I just call names? Anybody? Anybody? Don't be shy, please. Please, let's be bold. We are bold innovators. We are not shy, and none of our ideas is wrong. Everything is welcome. So anybody that wants to just, unmute, tell us how you encounter the technology, quantum computing, like just tell us anything you tell us. Anybody? Okay, I think I'll just call names instead. Joshua, do you mind sharing with us?
All right, thank you, Dave.
Yeah,
Good afternoon, everyone.
good afternoon.
For me personally, I don't really know much about these aspects of this quantum computing, but I've tried to watch some videos and do some research, and I've got to understand that it's not basically a new way or something to replace our classical and normal computers like the systems and the phones and everything, or more or less something that can help us kind of reach out to other parts of life and discoveries that we can't just basically do with our regular and classical computers. More or less like the illustration in one of the videos I watched, more or less like developing a boat to kind of discover the ocean. Not that it's coming to replace the cars, more or less to help us discover new areas.
Thank you very much for that. Very insightful. That was very insightful. Exactly, and that's why we're here. So, let me first of all, I think I'll just start with introduction. So, I'm Mojetilo Adivitola. I'm the founder and CEO of RealWorldSQL, a deep tech innovation lab with the mission to design African quantum decade. We see that Africa has missed out on so many technological revolutions. Talk about the semiconductors and so many other revolutions. We are just trying to play catch up, and we have to be honest with ourselves. And we have that once in a lifetime opportunity to shape a new technology. So quantum is not necessarily new. Like, I mean, there are companies that are already doing it for like 33 years. So you can tell by that. So, but we see an opportunity that this is a new technology. And if Africa is projected that by 2050, we have the largest population, the largest youthful population in the world, and also we are going to be having, and Africa has like major problems in the world. So this technology has a lot to offer us, and it's only by, not just by adopting it, like, oh, we are trying to adopt it the way we did with AI. We were doing a lot of research, the team and I, and we found out that currently in Nigeria, even in Nigeria, we currently don't really have like an AI policy. We do have like a strategy team working towards like, okay, coming up with AI policy, but yet you can see that we are back, like we're just far back. We're just trying to play catch up with technology. So our mission is simple. We don't want to play catch up. We want to lead, and Africa will lead in the quantum decade. So that's why we're here, and we decided to like have this quantum nexus session where we can have diverse perspective of people, designers, technologists, enthusiasts, developers come together, because the future is interdisciplinary. I tell you, it's interdisciplinary. Like having people from different perspectives, from different walks of life coming together to to understand how this technology now can contribute to human flourishing. And that's why we're here. I'm personally, I'm very interested in like emerging technologies. I was playing around with AI, IoE, Internet of Everywhere. And this year I just found quantum computing. Although I've been battling with, like, I've been interfacing with it, but I didn't really understand. So there was just a fellowship that came, and I decided, okay, this is a new technology. Let me just learn. And from there, started learning, and then I saw a lot of opportunity, and that's why we are here. We are not just here to like come and learn. We want to see opportunities, and we want to be able to go for it. I had an interesting conversation with our speaker. He's here with us today, and we're talking about Sam Altman. Sam Altman is not necessarily a technical guy. All he just saw was, he saw an opportunity and went in for it. There was a paper that Google released about AI and the GPT model and everything. And then what did he do? Just gathered people together. Let's see what we can build around this. And that's it. The ability to see the opportunity, and we want to be able to go for it. Not just seeing the opportunity. Many people see the opportunity, but they are not able to go for it. We have so many technological revolutions in the world. The likes of the assembly line by Henry Ford was one that made car accessible to everyone. Phones, Steve Jobs, and everything. So this is a new technology. Everybody is currently pushing towards quantum advantage and supremacy, but Africa is quite far behind. Although, yeah, we have research in countries like Morocco, South Africa, but still relatively low. And we as Nigerians, we know we are the trigger for Africa, and that's why we are taking it upon ourselves. That we want to create that spark in Africa. We want Africa to lead, and Africa will definitely lead. So yeah, and that's why we are here today. So I'll read the bio of our speaker. I don't want us to take much time. Let's just get into it, understand the technology, and then we can learn. So I'll read the bio of our speaker, and we'll get to it. So Oluwatobi is a software engineer specializing in front-end development. He spoke at the Open Source Community Africa Festival 2025 and is passionate about continuous learning and growth. He has contributed to open source projects and taken part in hackathons, notably the Polygon Africa 2022 hackathon. Outside of coding, he enjoys tending to his garden. So with so much honor, I want you to welcome Oluwatobi, as he's going to be taking us through quantum computing today, tomorrow, and you. Thank you very much, Toby. You're welcome. You can have the stage.
Thank you very much, Oluwa. Good day, everyone. Trust you all are doing great. Nice to be here to present quantum computing today, tomorrow, and you. And we'll be seeing how all of these affects you and how you yourself can position yourself in this technology that's in this field, that quantum field. Without much ado, I'll be sharing my screen. We'll walk through the slides, and then hopefully at the end of the session, I believe some of you might have some questions. We'll just discuss and see how it all goes from there. So quickly, I'm sharing my screen in a moment. All right. I believe you all can see my screen now.
Yes, we can.
Okay, great. So, welcome everyone. Just like Mojetula did say, I'm a software engineer, primarily focused on front-end technologies at the moment, but definitely I've had different stints out, different aspects of the technology. That's front-end, back-end, blockchain, and all of that. Passionate about continuous learning at all times, so that's why I've had quite a few experiences in all those places, but then I'm majorly focused on front-end systems at the moment. So for me, quantum computing actually piqued my interest this year too. And then I've actually done quite a good number of research on it. And I feel that it's one of those computing paradigms that people need to know about and people need to prepare themselves for, not in terms of just consumption, but for them to also be part and parcel of this whole movement. That's in terms of maybe creating algorithms and ensuring that we create toolings for quantum computing and making it much more democratized. So here we have the topic, quantum computing, today, tomorrow, and you. I believe to many of you, all the words, all the keywords in this topic is quite familiar, except for the word quantum, right? But then for some of you, you might recall the scene of this in this particular picture. It's actually a scene taken from a movie. And then for those who can't recall this particular scene, you might recall this scene, right? Where you have these set of people in their spacesuits looking as if they've got a package, right? For those who still can't really fathom what we have here, I believe this might give you an inkling into what we are looking at. So you can see here we have the 6 Infinity Stones, that is of the movie Avengers, the Endgame. And here you have the villain himself, right? Now, in this movie, that is where we had those other guys, that the other Avengers in the jumpsuits, pass through a tunnel, that is much more of a time machine, all based off the principles of quantum mechanics, so as to be able to travel back in time, retrieve those infinity stones, and then undo what Thanos did, right? Now, what is the whole concept of quantum computing itself? Quantum computing is based off the principles of quantum mechanics, which is much more about some superposed and some kind of entanglement of bits themselves, such that at the end of the day, these bits don't have a particular deterministic outcome. When we talk about deterministic outcome, that is, it's not a 0 or a 1 at a particular time, right? It's much more of a probability. Now, in modern computing, we know that the most basic building blocks of computing are the bits, or is the bit, right? You have the zeros and then the ones. And once you have both together, all stringed in a particular manner, they get to pass instructions to the computer to do some particular function. Now, in terms of that of quantum computing, we have each bit is much more of a probability. In modern computing, that's classical computing, you have it such that it's either a 0 or a 1. But here in quantum computing, it's a sum of the probability of either a 0 or a 1. Now let's just move further and see what we get to then. For instance, now you might have seen this image somewhere, right? This is much more of a quantum machine, right? This is a machine in a particular movie, which helped to take what is larger, shrink it into much more of a smaller size, and then sends it into the quantum realm. So this is much more of a portal into the quantum realm. And then that's actually from the movie Ant-Man and the Wasp, right? Now in here, you can see Ant-Man himself replicated severally. You have several versions, several replicas of Ant-Man, all looking at themselves and trying to figure out, okay, who is the true Ant-Man amongst all of us? But then this is much more of Ant-Man being in a probabilistic storm. Now, when we talk about a probabilistic storm, that is Ant-Man, the versions of Ant-Man in different states, all in all represented by probabilities. Now, all of these might feel a bit weird for now, but then we'll get back to this shortly. Now you can see that with that whole probabilistic state of Ant-Man, you have all of them coming together to solve a particular solution. Now, these probabilistic states of the bits, that's in terms of quantum and quantum computing itself, all come together to solve a particular problem. You have to combine them to solve a particular problem. And then here we see that Ant-Man and his probabilistic states are all coming together, trying to see how they can shrink down the energy core of Khan's machine. This is all taken from the movie Ant-Man and the Wasp. But then, now, let's look much more at quantum computing and all that we have today, what is happening at the moment, and then what we should have in the future. Now we have this graph which best illustrates the whole journey of quantum computing and that of classical computers. Now we have on the y-axis the simulation cost, and then the x-axis we have the circuit complexity. Now in terms of today's world, you can see this purple line marked today. We have all the classical computers lying to the left of this band, right? Now, in terms of simulation costs, you have simulation costs going up, and then you have circuit complexity increasing, and then you have quite a good number of classical computers, most best known as supercomputers, right? Having to be able to solve solutions right across these bands. But then we also have quantum computing also gaining some kind of traction, right? But then when we are to say we really have something called quantum advantage is when these quantum computers get to supersede the best supercomputer in terms of solving problems. So you can see this blue, this sky blue band here, this sky blue area, shaded area, represents the area of quantum advantage, where simulation cost increases, we have increased circuit complexity, that's in terms of on the quantum computing realm, but then at the end of the day, quantum computers end up solving it better than classical computers, right? That's all these sort of supercomputers. And at the end of the day, we are looking at having quantum computers with better error mitigation, because at this moment, what we have in terms of quantum computing is that it's very, very easy for the quantum computers to, or the quantum bits to get disrupted by either noise or temperature and all of that. So this whole graph, this whole image helps to illustrate the state of classical computers, the concept of quantum advantage, and where we are going to in terms of quantum computing itself. At the end of the day, we are all striving to achieve quantum advantage. That is where a quantum computer can solve problem much more better than a classical one. Now, you might wonder, okay, why should we even bother about quantum computing, right? But then I bring this to you. I believe quite a good number of you would recognize these images. As you can see, these are mobile phones, all used in probably early 2000s. Yes, you can see the Nokia 3310, the Samsung R220, and quite a good number of them. Here you have the Nokia Express Music. Some of you might have even used probably maybe the Nokia Express Music. I believe right now you are no longer using Nokia or any Express Music product. Now, okay, what about this? You can see the BlackBerry, you can see the Asha, the Nokia Asha, and then you can see the Motorola mobile phones. Most of these mobile phones are no longer in use. What we have now are the Android and then the iPhones, right? So what's actually there is this. You have decided that, okay, I need to upgrade, I need better compute power, that's for my mobile phones, so as to be able to do better things, be able to communicate and reach out to people. So how about that of other kind of problems you yourself don't even know about? Because for instance now, when the earlier phones, which I just did show came out, that was when they were all introduced, they seemed like a very, very novel technology. That is, you get to call someone and then the person picks up at the end of the line and then you get to communicate. But right now, we have moved away from just phone calls to calls. We've moved to video calls and all of that, which helps to improve even communication. So at the end of the day, this is all the whole goal of quantum computing itself. At the end of the day, we need to there are some kind of problems that we don't even know are problems at the moment. For instance, if you were to go back to the days of maybe the post office, right? And then you say, okay, there's no need for you to send letters anymore. People will wonder, okay, what do you expect us to do? We need to communicate. But then right now, we have mobile phones, which even helps us to be able to communicate in a real-time manner. Now, back to Michio Kaku, that is this man, this physicist over here, who talks about the mobile phone, right? Now, based off his book, The Physics of the Future, published in 2011, he says that your cell phone right now has much more compute power than the computer that powered NASA, which sent 2 astronauts to the moon back in 1969. So just the compute power of your mobile phone has and will continue to be able to do much more than the computer used to power a spaceship. Now, which computer is that? That's the Apollo guidance computer. It has 4 kilobytes of RAM, 70 kilobytes of ROM, and then it helped to land man on the moon. That's based off Apollo's 11 mission. So this computer did just basic calculations relevant for just mission critical calculations for that particular launch, right? It's not like our mobile phone, it's even way, way less than our mobile phones. You can see how bulky it is. But then we've been able to progress much more into better things even right now. Now, so at the end of the day, what are we trying to do? We're trying to solve problems classical computers solve in reasonable time. Now, some of these problems are even problems we ourselves do not even know about, or problems that we've not, or we know there are problems, but we just feel that, okay, it's the kind of problem that you just have to live with. Yeah, it has no solution. Now, but then at the end of the day, quantum computing and then the whole buzz around it has its own challenges, right? Now, first off is the noise, which I did mention earlier. They're actually very susceptible to noise, that the quantum computers themselves. But those who might have seen the image or the videos regarding quantum computers, you'd see that they are gigantic machines placed in specialized places and then maybe cooled with some kind of elements, probably all these cooling agents, so as to just keep the temperature down. Right? So they are very, very susceptible to noise, temperature, and all. Now, the ability to increase the number of qubits is actually one of those problems. That's in terms of its scalability, because you need to increase the amount of qubits a particular system can take. Now, based on the number of qubits, that now determines the number of problems or the kind of problems or the complexity of problems it can solve. For instance, now, if you were to go back to the basic arithmetic, right, back then in school, and then sometimes you would have to solve for 2 numbers, that is the addition of 2 numbers in base 2, right? Probably for those who are in Nigeria, there's a senior secondary 1 or probably in junior secondary 3, right? That's year 3 and year 4. At those points, you might have been introduced to the concept of binary numbers. And these are numbers that you get to use in mathematics. These are numbers that the computer actually understands. So with binary numbers, you get to learn how the computer gets to calculate. So just as you input 2 plus 2 in a computer, the computer doesn't see it as 2 plus 2. It sees it as binary 2 plus 2, that is 10, that's 1 0 plus 1 0, right? And then it does the binary summation there, finds their sum, and then returns it back in decimal. So now, for computers that can only handle 2 bits, right, they can only solve problems that have 2 bits in them, or that will give a 2-bit solution. But once the problems will give maybe like 3 bits, 4 bits, 8 bits, that's a byte. It ends up becoming much more complex for them. So here we have in quantum computing, we need to be able to increase the number of qubits in the quantum system. But then the problem is that it's not just increasing the number of qubits that it can handle, right? The more qubits you have, the more you need to error correct, the more errors you might have, the more noise you might also have coming from various bits, and then the more you need to make the whole system stable. So it's much more of an optimization problem at this point. Second, the third is cost. So quantum computers are very expensive now. Why are they actually expensive? Because of the specialized environment they are needed to operate, and also the specialized knowledge needed to even set them up in the first place. Okay, so that's why quantum computers are very, very expensive. They are not like the computers which we have now, all ubiquitous, you have it everywhere. Now, fourth is talent, right? You need special understanding of quantum mechanics, computer science, and engineering. And then we have very, very low talent pool, all for that. All of these requires good understanding of physics and mathematics. And to a large extent, most people shy away from mathematics, physics, and all those tough subjects, things that look much more abstract. So at the end of the day, this even pushes us down to, okay, we have even very, very small talent pool for the whole quantum computing. Now, but then based off all these challenges, which I did discuss, I believe it might have just rung a bell, right? We have scalability, we have issues with talent, we have issues with setting up the computers itself, and then noise. Now, these are very, very similar to first generation computer challenges. For those who might be familiar with the notion of first generation computers, these are all those computers that use vacuum tubes. That they are very large, they produce large amount of heat, they need cooling, and they're just for specialized usage. Right? These are the kind of computers that were even used to break German codes in World War II. But then, they had to use vacuum tubes. They needed to be cool. You can see this is a computer, very, very large. You can see how large it is. That's based off the image in the background, and then the man just standing there looking at the computer. Definitely from the image, you can even know that, okay, this man is actually a tall man, but then you can see how tall the computer is, much more taller. They actually look like servers, but then these are just basic computers doing basic calculations, which our computers right now do just on the fly. So you can see how related it is in terms of the challenges of quantum computing today, the strides the whole industry has been able to achieve, and even looking back at what we have in the first generation computers. Now, at the end of the day, we have corporate interest in quantum computing, and first off is HSBC. That's the Hong Kong and Shanghai Banking Corporation. At the HSBC, I hope I'm correct with that's based on the name anyway. But then this is much more of a bank which is exploring how to use quantum computing to improve its own services and products. One of the foremost things which they've done of recent, I think in September, is to be able to demonstrate how quantum-enabled algorithm trading, that's in terms of bonds, has been able to even outperform that of classical computers by I think about 34%, all in collaboration with IBM. So all of these, to a large extent, they've not shown us or presented how that was done. Quite a good number of companies actually hiding all of this with much more of their own intellectual property, and then they're just trying to ensure that they are one of the first to get those kind of breakthroughs. But then they've been able to report that they've even gotten like 34% better results in terms of quantum-enabled algorithm trading in terms of bonds. So when we talk about algorithm trading, that is where you get to take your portfolio, pass it off to an algorithm, and then say, okay, optimize this algorithm. I'm optimizing for price. I need to get lots of profit from this my portfolio. You run the algorithm, the algorithm should know what to do and then ensure that I get the maximum profit from base of my portfolio. So that is what HSBC has been able to do, all in collaboration with IBM. The second is Google. And then one of the main things they've done is to have this AI hardware, that's the Willow chip. That's the quantum AI hardware. What I like about Google is that instead of just having it as quantum only, where they say, okay, quantum will solve quite a good number of problems, we have quantum all merged with AI. So I think to a large extent for Google, they play in their own sense, or in what they have, that's their own roadmap. It's much more of seeing how quantum will be able to accelerate AI. That is, in terms of training, for instance, training of AI, all those models is actually quite expensive now. It takes quite a good amount of time. But then if, for instance, we have quantum computing, which can do this much more faster, be able to train models much more faster, use lesser power, and then you'll be able to even get better results and optimize and then change things much more quickly, right? For Google, they've been able to also come up with a software called SEC, and then it's much more of a Python software library anyway, which is used to design circuits. That is the quantum computing circuits that can run on quantum computers. And of recent, just a few weeks ago, they've also been able to demonstrate that they've been able to reach quantum advantage. That's using the Willow chip. They're able to run a particular algorithm. I think it's called the quantum echoes. And they've been able to show that it's run much more better than the best classical computer. Google has access to the best kind of compute power which they need. So they've actually said in their article that is said by their CEO, Sundar Pichai. He's been able to say, okay, we've reached quantum advantage using the Willow chip. Now, let's go to that of Microsoft. Early on in the year, Microsoft released a chip, Majorana 1. Now, what's quite fascinating about this chip is that they've seen that, okay, this chip is much more of an architecture which offers a pathway into ensuring that we have more qubits on something as small as this, which is handheld. You can see it in that person's palm, right? And then for this particular chip, Microsoft has said that it's even less prone to noise, and then it even works better. But then, to a large extent, most of these big tech companies, they would get to tell you their experiments, tell you what they've done, but to a large extent, you may not really see it for now, because quite a good number of them are trying to ensure that, okay, all our progress, all what we get to do is to our own benefit. That's the company's own benefit at the end of the day, so that they'll be able to make more money out of it. Without more money, be able to get to whatever path they need to get to quickly, faster, before other competitors do, and then they get to monetize that. Now, the next one is IBM, which has Qiskit, which is the most popular performant software stack for quantum computing and algorithms research. All of these is also a Python. This Qiskit is actually a Python library, which you can use to create or to simulate quantum circuits and then run them on quantum computers. IBM actually hosts quantum computers, so you get to access quantum compute via the cloud, and then you can get to do some work around that. Also, they have the Qiskit Advocate program, which helps to deliver resource for the next generation of quantum community leaders. And to a large extent, I will encourage as many to check out that program and see how well we get to learn about it. So for those who haven't seen like some kind of image about quantum computers, so here you have this bit here. You have a lady there looking at a particular structure. That is the whole quantum computing setup. So now, how about you, right? There is someone called Soren Kierkegaard, and then he did give a story about a preacher doc. A preacher doc gets his own congregation and preaches to them, okay, you can fly, you can fly. And they were all happy, they all hailed him, yes, go on, preacher, Yes, we can fly. But then guess what? At the end of the whole service, they all went back home paddling instead of even trying to see if they would be able to flap their wings. So how does all of this concern you? I think first and foremost is for you to learn Python. What is quite obvious here is that the big tech companies, both Google and IBM, they all use Python to create these libraries, which helps to create all these quantum circuits. So these Python libraries that help create quantum circuits are all based off Python. That's the sec, and then the Qiskit based off the companies Google and IBM. So it's much more of a no-brainer. Just go learn Python first, so that at the end of the day you'll be able to design those circuits. The next is IBM Qiskit Advocate Program, which is as I said earlier, you will get to learn more about computing, and then you can even become an IBM Qiskit advocate. So you get to talk more about quantum computing, you talk more about Qiskit and how people can get to use Qiskit. And to a large extent, this is an open source tool. That's the Qiskit itself. So if you are a developer, you can contribute to the Qiskit project, and it also serves as one of those good points for you and for your whole career. So these are the major points which I've got. But then let's look at this quickly. To a large extent, you might have heard of the Schrodinger's cat, right? Because based off the image which I showed you of Ant-Man in a probabilistic storm, he was told that, hey, you're in a probabilistic storm, you are now Schrodinger's cat. Now, what's Schrodinger's cat? It's actually a thought experiment by Erwin Schrödinger. And this thought experiment states that, okay, if you have a cat, right, or if you have two cats, right, and then you place a radioactive substance in a box and also place the cat there. And after probably like an hour, the cat has a 50% chance of either dying or living, right? Let's just assume it's just one cat, right, placed in a box. Now, what's the state of the cat after 1 hour? Is it dead or alive, right? Now, for quite a good number of you may say, okay, it will be dead. Some may say it will be alive. But before you open the box, what's stated in that whole thought experiment is that the cat is both dead and alive. Because you don't know, you have no insight. You can't actually see what's inside the box because everything is just a black box, right? Until you open the box before you're able to know whether the cat's actually dead or alive. But then once you open it, that's when you either ascertain that it's either dead or alive, because this is much more of a 50-50 probabilistic outcome. Now, this all takes us to someone whom quite a good number of people know, especially in Nigeria. This is Hilda Basi, in her just concluded Guinness World Record event. So she's a two-time Guinness World Record holder, and then trying to cook the largest pot of jollof rice. But then what happened there is that she also had a friend, right, called Eniola. Eniola went with his cooler and then said, okay, now that you have the jollof rice, we ourselves also want to place it in the cooler to go and enjoy all by ourselves. But then after enjoying the jollof rice to a large extent, he realized that, hey, this is too much for I and my cousin to just enjoy, because he also caught up with his cousin there. They both enjoyed the jollof rice, and then they were quite full. He said, oh, it's time for us to make some money. Let's go sell jollof rice to people. And here comes this man, right? This young man who steps in and collects the jollof rice in his palm, right in his palm. Now, looking at this state, you would see that the jollof rice is very well in his palm. But if you look at the picture closely, you would see that he had to pass his hand through the bars. Now, in this state, would you say that he was able to get his jollof rice, or the jollof rice went to the ground, or he wasn't? I saw these on Twitter, and then someone did say, hey, This one is Schrodinger's jollof. The rice is both in his palm and on the ground. So you can actually see that, yes, you have the rice in his palm, right? But then if you now factor in, okay, how would he take his hands out? That is through those bars. You know that a significant amount of those rice would actually have to fall to the ground. So it's much more of a Schrodinger's jollof. But then, yes, I know we've all talked about quantum computing and the whole excitement about it and how things work and all of that. But then there are still some skeptics, right? There's still some skepticism about quantum computing that, okay, is quantum computing true? Will it work? How can this work? We've actually seen quite a good number of that. And I've picked quite a good number of screenshots from Twitter. First off is we have Martin, right? Martin Shkreli. He says he will never not be short quantum. Either I will be dead or the stocks will be at book value. Stop asking. So this means that he will keep on shorting quantum computing and all the whole startups regarding quantum computing forever. That's based off what he did tweet. And this all did emanate from talking about investment in quantum computing startups, right? You have some startups like IonQ that said, okay, they are also working on quantum computing, quantum computer, and they are doing the various things there. Yes, they're actually making strides there, but then how well or how much of a progress have they done, or how much of a progress have they been able to achieve? Now, the next one is this other person here who says, hey, quantum computing is fake. It will never scale. It's just a psyops, and those who are in the physics department just need funding, so they just keep pushing it out. And hey, they just need some money. Someone did affirm to that his dad was even a physicist in the thousands. That's probably in the 1900s, probably maybe in the 2000s, early 2000s, right? And then he said all of this whole hype about quantum computing that it will never happen as long as his dad is alive. And then you have this other one where we have Jensen Huang, that is the CEO of NVIDIA, say, hey, quantum is just some mumbo jumbo. You have to talk about some entanglement, some superimpose, some kind of teleportation. Hey, what's all those mumbo jumbo? And then we have back home, we have this other user, Twitter user. His name is, I think, Dalu. Yes, Dalu Igwe. I think that's his name. And then he said, hey, he's also gone into the quantum computing rabbit hole, and he's shorting all the stocks, the quantum computing stocks, down to zero, because it seems as if it's just a fad. People are just riding on the wave, and it has nothing tangible to offer. However, after seeing this tweet by Sundar Pichai, that is regarding the whole quantum echoes and all that Google has been able to achieve, he did say that, yes, he's not bullish on any quantum stock, but then he'll be loading up on Google because at least Google is making some stride, right? Now, where does all of this take us to? I would really say that as much as quantum computing is much more of a developing field, people are getting to know more about it. People are keen into it and making and finding several discoveries. It is best to stick with all these big techs that have deep pockets, who also know or who also have access to the technologies. They also have access to the talent who will be able to even carry out various research for them, right? It's best to stick with all these big tech, Google, IBM, Microsoft, and then see what they're doing. Aside from that, I know that quite a good number of people will be or are actually skeptical. Yes, it's that fine. You should be skeptical. But then at the end of the day, you should also not be skeptical enough not to even try it out, right? That's tried out in terms of positioning yourself to see how all of this goes. Now, if you're to go back onto just our classical computers, you know, at the base level, our classical computers use zeros and ones. That is the machine code. zeros and ones. That's the machine code. But no, none of us is actually having to type 0 and 1 just to make a program. None of us is having to write assembly language. At the point, I wrote some kind of assembly language back then in school, just to add some numbers, having to put in some interrupts, interrupt 20, interrupt 21, and all of those CPU codes, right? But right now, I don't interact with all of those. I interact with high-level languages, Java, C#, Python, Rust, and all of those. Now, what I'm saying is that at this point, and what I've seen thus far, is that both SEC and Qiskit, which are used to create quantum circuits or to simulate those quantum circuits, are much more focused on building those circuits just using the codes. They are building the circuits themselves. So you get to use Python to build a circuit. But right now, of a truth, no one is actually building a circuit with us on all of these classical computers. You just write your codes. Okay, I want you to do this, do that, do that. Everything compiles down to machine level. It runs and does what you want. You don't have to worry about building any circuits or building any kind of interconnection. So I think to a large extent, whoever is able to build a much more of an application layer to all of those quantum computing circuit building framework would actually be able to push up whichever person or group of people is able to do that, will actually be able to make much more better strides in this whole industry. For instance, now that of AI, right? If you should ask most people, they'll tell you, hey, ChatGPT is AI. But then AI has been here for so long. Back then in school, I did some things regarding recommender systems, but all of these are siloed AIs where you get to use customers' data, do market basket analysis, and then you get to see, okay, since a person in this particular kind of demography picked this particular kind of item, then most likely whoever picks this kind of items that is in a shopping cart might most likely pick another, and then they get to recommend it. Once you recommend it, if the person picks it, that all adds or feeds back into the recommender system. But these are all siloed programs, much more specific usage of AI, and AI has been in use for this long. Even PayPal has been using AI for this long, so as to be able to detect fraud, because they get to process lots of transactions per time. But then right now, because there is much more of a democratization of AI, that is using of ChatGPT, which everybody can just type in a question in ChatGPT and then you get to have answers, and it does research for you, or it regurgitates what it has, and then it gets to align it much more based off what you said. So it understands what you said or what the prompt you're giving it. Most people actually feel that, hey, AI just started, or this is when AI started, but AI has been here for quite long. But people haven't been using it. Those who have been using it are much more of the researchers. They've been much more looking at the mathematical part of it, the machine learning algorithms, the support vector machine, k-means, clustering, and all of that to solve problems. They've not been able to build that application layer which democratizes it. So that's what ChatGPT has done. That's what OpenAI has been able to do. And then everybody now knows AI. Everybody now uses it. So at the end of the day, this is what I would say. Aim for the moon. If you miss, you might hit a star. Why? In terms of quantum computing itself, first and foremost, one of the things which I've said is, hey, learn Python. Even if you don't get to use Python for quantum computing, you've learned the skill needed in the application of AI. So you might end up becoming an AI developer, right? And you get to plug things together using Python, and then you get to have your AI tools get to work. So at the end of the day, even as we look at quantum computing, it's much more of a developing field. It's not yet there yet, but then you can as well position yourself by learning Python. And even if you don't get to use it for the quantum computing just like you wanted, you could as well use it for artificial intelligence, just as we have right now. For me, just learning about quantum computing has even forced me to go back to the basics. Basics of what? Basics of mathematics. Like right now, I've had to go through some courses on Khan Academy to learn much more about linear algebra. Yes, I did it back then in school, but I just needed to refresh my memory. I had to learn quite a good number of bits about vectors, coordinates, and all of that, because these are much more the building blocks to be able to represent the information, the probabilistic states of of quantum computing, of qubits in quantum computing. So that's basically it. Thank you very much. My name is Oluwatobi Akanji. Once again, you can check me out on LinkedIn. Follow me on LinkedIn at Oluwatobi Akanji, or on Twitter, that's X, at Akanji Toby S. I'll definitely share these slides with you all. Thank you all for listening.
Thank you very much, Toby, for that insightful session. It was really packed, and you unpacked a lot of stuff for us, and really excited. Learned a lot, and we'll be opening up the floor for questions and answer if you have any questions. So before that, but I think just few things. For me, I think that I don't know why I just have issues with big tech companies like Google, IBM, and I sometimes I just feel like there's a lot of buzz from them. Some of them are just leveraging PRs to create that noise. And but most importantly, I think another thing is with quantum is that we need to not just doing the major challenge now is there are a lot of research, everybody's pushing towards quantum advantage, but we need solutions. I don't know, solution, should I call it solution tailored research? That's okay. How can we demonstrate quantum advantage to solve a particular problem? We talk about the likes of optimization problems, AI, AI and all those things. So we have so many problems. So I think most importantly is how do we identify those problems? Like now in Africa, for me, one of the problems I identified was greed, like energy greed and everything. We face a lot of problems with our energy system, just in like Nigeria, where grid is always collapsing every time, every time, every time. So how can we have tailored solutions for specific industries? We have the finance. Yes, I think the push in finance is quite all right, but then we need tailored based solutions. So when I look at big tech, I was speaking with one of my lecturers and I was talking about IBM. It was like I understood the point it was coming from. Like IBM, these big tech companies, they have been there for long. And most times they just try to leverage that PR and everything and have the money point into research. And I think that's another problem with research. Take for example, let me use Africa. We have a lot of researchers that have done research. Like when you look at universities, I think that's why sometimes students don't feel like they want to be in the academic session or doing the research, because it feels like we've done research, but the problem is we've not been able to create value for our research. And that's one of the things we're also trying to do in the company, is that not just let's do the research, have the breakthrough technology. Fine, those are very good. But we need to be able to create value from our research. Value, value from our research. Because you can do research and it just ends up on the shelf and then we're not able to create value from our research. So all I'm saying to everybody here is that as you look at going into quantum computing, how it's going to affect you, I want you to look at not just the breakthrough of the technology, but how can you create value? Because how can you create enough value for yourself and capture it? We talked about Sam Altman. It's just because they saw the opportunity and they were able to create value and capture the value. Man, look at what OpenAI is doing today. If people knew that OpenAI will be doing that now, they would have invested. I know a lot of skeptics about quantum computing. It's normal. Everybody just try to make noise on Twitter, but then we get to the point where people will see, oh, if you have done this, and that's why we are here. We don't want to miss that moment. Nobody knew that just that open AI stuff. We just shift the industry and everything. It's shifted the industry, and that's one of the things quantum is also going to do. It's going to affect business models. By the time quantum has reached quantum advantage, a lot of business model will be affected. Companies will try to play catch up. And look at let me use the of Intel. Intel has gone out of market. they even acknowledged it that they've lost the race, honestly speaking, because NVIDIA has already just NVIDIA has bombed. So as we are studying these things, it's very important that we look at how we can create value and capture value. So yeah, if you have any question, please, I would like you to feel free, unmute your mic. You can turn on your camera and ask any questions. Anybody with question? Please, let's ask question. That's why we are here. We are not here to just have the speaker speak, but we contribute. And that's one of the things we are looking to do also in Africa. These companies outside the country try to they just try to create a mold around things. I think another thing that will quantum forward is the community, like different people coming in. Let's look at this technology and how we can push it forward. So if you have any question, please go ahead and ask your question. You can drop it in the chat or you can unmute. Feel free to unmute. I'm waiting for us to ask questions. Are you afraid of technology?
It seems we don't have. Okay. Since we don't have any question. Hope. Okay, I just saw a message where you said my slide wasn't moving. Hope it actually did.
Yeah, it was. Yeah, I refreshed my network, so it was.
Oh, that's nice. So in terms of quantum compute and all of that, I think what we as Africa into much more is in terms of quantum compute algorithms. Now, we don't have access to those kind of compute powers. That's the big take and all of that.
Yeah.
So we have the brain power to be able to create algorithms that solve problems, right? So we should focus much more, first off, in terms of algorithms. Second off, in terms of having much more of an application layer to these Python libraries like Qiskit and Sec, because all of these, they're just combining circuits together. But the truth, no one will, if you want to study how to program, right? No one would have to go down and start to learn different matrices and Hadamard gates and AND gates and whatever gates, right? It's too much low level. So
yeah,
for whoever or the group of people who can have a much more better layer above those kind of quantum circuit creation, such that you just get to write the code, just what you want, and then the whole circuit just gets created at the background. I think those are actually great ideas, and those are actually great things to be done in terms of quantum computing at the moment.
Yeah, you're right. Just like I said, the application layer. Another thing is even like in terms of quantum softwares, like those software that can create those create those abstractions where you don't have to deal with cycles. Because if you go to like IBM cloud computing platform, you are just there and like, what is this? Like circuit. Yeah, trying to understand it. Exactly. So we need those things too. And I know those things are a bit connected to the infrastructure too, because we cannot just build software that cannot run on an infrastructure. So we also need those collaborations actually. Yeah, somebody's asking a question. Though I think we addressed the question, but yeah, you can just go by it again. As of now, are there limitations or challenges of quantum computing?
Yeah, to a large extent, yes, we have challenges. That's why you have everyone trying to achieve quantum advantage. The bits which we have, for instance, now on your phone, you have probably your phone has made like, let me see, maybe it's a 64 gig phone, right? But then that's in terms of the memory space. But then previously, if you had to get maybe let's say maybe 2 gigabytes, so 2 gigabytes maybe system would be something very, very large. It wouldn't be something small, which we have at the moment. But as time went by, we were able to shrink the memory and then we have it this small. Now, this is actually one of the problems we have in quantum computing. We have the qubits, right? We've not been able to have enough qubits to be able to solve enough problems or solve large problems because everything runs on qubits. So we don't have enough qubits to be able to solve enough problems. And then the problem is that the more you increase more qubits, the more you need to deal with error correction because those qubits get interfered. We have temperature, noise, and all of that. So you need to look, okay, how do you get to correct all of those errors? So those are actually one of those issues. And then we also have talent, right? That's actually one of those main things which this whole webinar is needs to address. In terms of talents, right now you have to deal with mathematics, physics, and all those big stuff. But then we also need talents that will be able to dump down all of those things so that we're able to deal with things at a much more high level. For instance, now you're interacting with ChatGPT, you're enjoying the flow. You don't even know that, okay, this was all built using neural networks. Probably neural networks, this is even your first time of hearing something about neural networks. If I start to talk about how neural networks work, how you get to split things into numbers, how you get to have it into, break them into tokens, and then
Yeah.
pass it through each of those neurons, the different things in between and back propagation and all of those jargons. You'd be like, hey, just spare me. I don't even want AI anymore. But right now, you working on ChatGPT, you type it, you it brings this out for you. You say, hey, change my picture to Bill style. It changes it. You're happy. So we are looking for people who will be able to dump the whole technical stuff in quantum down, such that human beings, those who have or who don't have the patience to learn all those technical things, will be able to, yeah, gain from it.
Yeah, you're very right. Thank you so much for the answer, which is really important. We need the talent. But I think another bigger challenge we have is the education. You see, like the access to the education is high, like very, very high. Imagine you want to access like top-notch quantum education, you have to probably go in for a master's or a
Yeah.
PhD. And I think that's that's one area we're also looking at, is that how can we scale quantum education in Africa? Because the more the education is available, the more accessibility to it, the better it becomes. When we talk about now, it's easy to learn tech. Everybody's learning tech. Tech has even become everything that people learn. Why are you learning? I'm learning tech. I'm learning this because the educations and those things have become so accessible that I can go online and the people say I'm a self-taught developer, I'm a self-taught designer because there are resources that are available. But with quantum, we have that the barrier of entry is very high. And
Yeah.
we are looking to like how can we like create a very scalable education system where it's easy to access it because when is easier for people to access it, it gives that opportunity. People come inside and begin to tinker with things and everything. And one of us that's leading us to even one of the things we're trying to do is that how can we like in universities, how can we create the awareness about the quantum technology where we can start having quantum clubs that people can be coming together, tinker with the technology, start learning about it and everything. And definitely we might need partnerships, outside there with companies that provide cloud access like IBM. I think one of the companies I'm personally like intrigued with is IQM. I think IQM, it's quite, yeah, they're not like they're the largest in Europe, pushing the quantum in Europe. So I've seen a lot of things they are doing. IBM is trying, Google are trying, but then I think IQM is trying. So we need those type of partnership, those collaborations, sparking those innovations in schools and everything, because whether we like it or not, the computers we have today is the work of some people trying to like bring it down. And the more they make things very accessible, like now ChatGPT is very accessible, but then if you look at the back, the amount of money they're making from it is very, very much. So we need things like that. Like we need to be builders. Let me say that we need to not just we don't just want to be consuming technology, just use, but we need innovators to come up. And that's one of the things we are trying to do here. Yeah, I see somebody has an hand raised. Yeah, you can go ahead, please.
Okay, okay, thank you so much, Mr. Oluwatobi, for that. Thank you, everyone. I wanted to ask, I think I asked Dave this some times ago, and the question popped again. Now, currently, we don't have access to the hardware, like to building it, yes, in Africa or in Nigeria. And companies like IBM has that, can only be accessed through cloud. Now, that access is quite expensive. So if we are thinking of making the education and the awareness open to them, there needs to be the practical aspect where they can actually access it. And we know deep down that IBM that is offering the cloud access is quite expensive. So my question is there a way we can um, sort of buy an IBM cloud space, right, and then make it I don't know how to structure this question, and then like duplicate it, make it cheaper so others can access it.
Yes, based off your question, if I should understand it, it's much more like if you ventured into this fractionalization of shares, right? Fractionalization of stocks. You get to see people buy maybe stocks on different platforms where you see maybe like Bamboo, Trove, and all of that, and then they can't buy a whole of Apple shares, so it gets fractionalized. You can buy maybe like, let me say, maybe like $100 worth of Apple shares. Actually, Apple shares are not fractionalized, but then all these platforms have been able to fractionalize it. I think that's what you're talking about, right? Such that you'll be able to buy it in bulk and then fractionalize it for others. Yes. Okay, that's great. I can see the thumbs up. Yes. So for now, honestly, I don't know if there's a kind of way to do that. But what I also see is that right now you can stimulate like all these algorithms. For me, what I just see the major advantage or the major thing we over here in Africa and quite a good number of people who don't have access to the tech or who feel the tech is actually expensive can actually do is just run simulations. You could be able to run the simulations on your computers, and that's good. Then if you really feel that, okay, yes, this is something that we need to collaborate and then run it on the actual hardware itself, then you can connect, get in touch with IBM, do the subscription and all of that. But in terms of being able to pull resources together so as to be able to fractionalize it, I think that would most likely need to come from IBM themselves. However, I know that aside from IBM, quite a good number of us are done talking about IBM. I know that Amazon, although I've not done much research on that, Amazon also has their own platform that is this bracket. If you should check out Amazon bracket, I think they also got some things to do with quantum computing on Amazon bracket. So if you should check it out and just wait whether IBM's price offering is higher than that of the Amazon bracket, you can just go for Amazon bracket. Actually, if you even check even cloud computers, just looking at cloud computing in general, and then you look at the price of things and all of that, you would agree with me that in terms of usage and all, they're also quite expensive. Even right now, if you have to train maybe like AI models, right? For you to be able to maybe buy your own hardware, set it up, train and do everything on your own hardware is kind of expensive. Quite a good number of people are just leveraging on having access to cloud, everything all hosted on cloud and putting it up, connect, and then run their whole workloads there. Which also brings me to the point of all of these being much more cyclical, just like a cycle, right? If you can recall, there was a time, or if you might have read different stories regarding maybe Bill Gates while he was young. You don't have direct access to a mainframe computer. There are terminals which are connected to those mainframe computers that run your workload, right? So this whole thing is quite similar to the concept of cloud, to where we have our own normal computers, but we have internet access to those cloud computing machines that run our workloads. So back to the question regarding being able to fractionalize access to those quantum computing resources. I think to a large extent it needs to come from the company themselves. If not, if they should know that, okay, yeah, someone is trying to fractionalize it without their knowledge, they'll definitely block it.
Yes.
Yeah, they'll definitely block the access. And then you can look at IBM's work, what IBM has in terms of their pricing, check out Amazon bracket, and probably Amazon bracket might even be cheaper because Amazon has been doing so many cloud stuff, much more than IBM. Yes, IBM too does cloud, but Amazon is much more of what most enterprises use. So I think to just juxtapose that for IBM and Amazon bracket, see whichever one works, and then you can get to work with that.
Oh, thank you very much. I think to add to that, I would like to say that I understand the point of like fractionalizing it, but um, this like quantum system, the original hardware that is even like what you are connecting, maybe the cloud, it's just like probably like a data center too that has the number of cloud computing or the number of quantum computers too, and some of them are limited by bits. I think by the qubits, right? So
Yeah.
some of them are maybe 50 qubits, 100 qubits, and all those things. So definitely, I think fractionalizing it. I'm not personally the way I'm seeing it. I'm not sure fractionalizing it might be able to work. Probably because of where we are currently. Probably as we advance, like as we go, as we advance in like as we move towards quantum advantage and everything, we might get to that point where things like that is possible. Because even with IBM, you just have it like you have like a number of days to do the trial. It's not like it's available because of how expensive the technology is, how to manage and all those things. So yeah, and we're just looking at innovations around how to work around on these things, and I think that's really amazing. So yeah, thank you so much for that question, and thank you so much for the answer. So yeah, is there anybody that has any question before we come to the close of today's session? Next week we're going to be having another session, a very insightful session again, where we'll be exploring another aspect of quantum computing and having another speaker come to tell, just to talk to us about the applications and all this. And so it's really, really like very interesting when we have this conversation around the technology. So go ahead, just research more. We are still at the very early stage, just like you said, where we are still at the low level, and that's where it is. But by the time we are getting to like 2030, 2040, things will have changed a lot. And we need to build the future. We don't like drag our feet. People have like different perspective of the future where they just let's just sit down there. We don't take risks and everything. It's a risk, but then we need, because of the future, we don't want to be just adopters. Like the honest truth is we've missed out on AI already. Forget about AI. Everybody's just trying to play catch up. Like people talking about AI, sometimes I just look at them and like, yeah, it's good, but come on, we've missed out already on this. But there's another one coming, which we don't want to miss out, and bringing those things together from AI, because now currently AI is even helping, like AI is helping quantum computing. Quantum computing is going to help AI. So you see that there's a lot of application, and we are still at the very beginning stage. So please, okay, somebody has a question. You've probably said it when you spoke about learning Python. But let me still ask, what's the way forward for us now? Like the you. Okay, do you have anything?
Yeah, the you. The way forward now, first off, learn the basics of quantum computing. Just like you are here, first off, you started to learn the basics of quantum computing. Second off, learn about Python, right? When you learn about Python, you'll be able to write codes in Python. And then because these SEC and Qiskit, they are all Python libraries, all used to build quantum circuits. They are all based off Python. That will enable you to be able to create circuits. Then after that, you can now look at, okay, how can I create algorithms? How can I create a layer which abstracts that application, that circuit creation? Because definitely none of us or no programmer is actually creating any circuit at the moment. So why should anybody have to settle down to start learning about Hadamard gates, AND gates, and all those different kinds of gates just to create something in quantum computing? So you can also look at that then, okay, how can I create something that abstracts that? So that now brings it to you. Now, aside from that, you can also apply the route of maybe advocacy, right? So you can look at this IBM Qiskit Advocate program. You can become an advocate, and then you get to keep abreast of all the progress in the whole quantum computing realm, and also inform the tech community about that. With that also boosts your own profile. That is for you. And at the end of the day, even when we have something very, very tangible in terms of quantum computing, since you've been updating your knowledge, know more about it, you won't be updating the community on it. You might even end up being one of those leading voices regarding quantum computing. So this also leads to you. You mustn't just focus on just the technical stuff. You can also focus on the advocacy. That's in terms of giving talks and getting to show different demos and get to advocate for quantum computing.
Thank you very much. I think I would like to add that, or what I would like to see is that someone that said it's in the last like quantum roundtable hosted by the Africa Quantum Consortium. He said move from being quantum curious to quantum capable. We need to move from that to just having the curiosity. Oh, it's a new technology. What's it about? How do I learn it or everything? Move from that to being capable. Because one thing about technology is that people just, that thing on LinkedIn, you say, I'm an enthusiast. How long will you be an enthusiast? Come on. You've got to move from being you've got to move from being an enthusiast to being capable and sitting down with the technology. It's more like, what can I solve with this technology? Like looking into the future and forecasting and forecasting, like, okay, where are we coming from? Because it's very important. History is like the bedrock of innovation for the future. So look back, where are we coming from and where are we going to? Like, we should be asking that question. Where do you see technology going to? Where do you see technology with AI now and everything, the push towards AGI and everything? Where is technology going to? So we need to look into that. And just like somebody mentioned earlier, that you see, this quantum is not necessarily going to replace classical computers, but then there are different areas we have not explored. I mean, so many areas we have not explored in the world. Like, if there's any thing that is making me push towards quantum advantage, is the fact that I see like nature has like nature simulation, like the ability to unlock intelligent designs in nature and translating them, taking those designs, because nature is very intelligent, like taking those designs and applying it to how we build our ecosystems, build our cities and everything. So which is really amazing. So thank you so much everyone for your time. Thank you, Joshua. Thank you, Collins. Thank you, Funshaw. Thank you, Moses. Thank you, Lukman. Thank you, Daniel. Thank you, Friday, for joining us for today's session. It was very insightful. And without you, we will not be here. So looking forward to next week. The flyer for the next quantum section will be out tomorrow. And then we also, so let's continue the conversations on the WhatsApp platform, and then just spark the interest. I don't know. So I want us to do something before we go. If you are where you can, like turn on your camera, it's really nice. Let's have a picture, because we know that something has started. And yeah, when we look back in years to come, we'll see that, oh, what started like a small seed has grown so large. So if you are there and you can like, just like turn on your camera, please actually do that so we can actually take a picture. Anybody, or if you are there, anybody, I can see only few people. Nobody has turned on their camera. Okay, good, good. Who again wants to turn on his camera? Who again? Okay. Anybody again that wants to turn on his camera? All right. So thank you very much, everyone. See you next week, same time. Have a wonderful. Thank you so much, Toby, for coming to speak. I really appreciate it. Looking up to catch up soon again.
Yes.
All right. Thank you. Bye, everyone.
Thanks. Yeah. Bye. Have a nice time.
Yeah. And go for everybody.
Dave, Dave, you're come on. What do you know?